More than 12 billion miles from Earth, well beyond the invisible bubble created by the Sun, a single spacecraft continues its remarkable journey through a region no human has ever explored firsthand. It was never expected to reach this point. Launched in 1977, Voyager 2 was built with technology that now seems almost unimaginable by modern standards. Its onboard computers possessed only a tiny fraction of the processing power found in today's everyday devices. Even so, it was entrusted with one of the most ambitious missions ever attempted. Its assignment appeared simple enough. Visit the giant planets of the outer solar system, collect scientific observations, transmit those discoveries back to Earth, and eventually fade into silence as its power slowly declined. History had other plans. Nearly 5 decades later, Voyager 2 remains the longest operating spacecraft ever built and the only probe to have visited Jupiter, Saturn, Uranus, and Neptune before continuing into interstellar space. Every transmission it sends today spends more than 22 hours traveling across billions of miles before reaching Earth's giant radio antennas. Communication has become an exercise in extraordinary patience. A command transmitted from Earth requires almost an entire day to reach the spacecraft, and another 22 hours pass before engineers receive its reply. Even the smallest adjustment can become a process lasting nearly 2 full days. Despite its age and steadily decreasing power supply, Voyager 2 continues returning priceless information from a region that no other functioning spacecraft has explored. In recent years, those measurements have become increasingly surprising. Scientists once believed the environment beyond the heliosphere would be relatively calm compared with the constantly changing conditions closer to the Sun. Instead, Voyager has detected unexpected variations in plasma density, unusual magnetic field behavior, and subtle changes that challenge decades of scientific predictions. Occasional communication problems caused by aging hardware have added extra challenges, but they have also demonstrated something extraordinary. Even after almost 50 years, Voyager 2 continues expanding humanity's knowledge of the universe. None of these discoveries point toward alien civilizations or mysterious artificial transmissions. The real story is even more fascinating. Voyager has shown that the enormous space between the stars is far from empty. It is filled with invisible activity, revealing an interstellar environment that is much more dynamic than researchers once imagined. Rather than simply leaving the solar system behind, the spacecraft has entered an entirely different cosmic neighborhood where the Sun's influence gradually blends with the enormous forces shaping our galaxy. The journey toward that discovery actually began many years before Voyager ever left Earth. In 1965, NASA engineer Gary Flandreau noticed an incredibly rare opportunity hidden within the motions of the planets. His calculations revealed that Jupiter, Saturn, Uranus, and Neptune would soon line up in a unique arrangement that occurs only about once every 176 years. This rare alignment meant a spacecraft could use each giant planet's gravity as a natural accelerator, gaining speed without carrying impossible amounts of fuel. Instead of launching separate missions to each distant world, a single spacecraft could visit them one after another by following the perfect gravitational pathway. Recognizing the historic opportunity, NASA built 2 nearly identical spacecraft. Voyager 2 launched first in August 1977, while Voyager 1 followed only a few weeks later. Although Voyager 1 eventually moved ahead on a faster trajectory, Voyager 2 followed the only route capable of reaching all 4 giant planets. Its discoveries transformed planetary science forever. At Jupiter, Voyager revealed an astonishing world dominated by enormous storms, intense radiation belts, powerful magnetic fields, and one of the greatest surprises in space exploration. Its cameras captured active volcanoes erupting across the surface of Io, marking the first time scientists had ever witnessed volcanic activity beyond Earth. Meanwhile, close observations of Europa strengthened the possibility that an immense ocean may exist beneath its frozen crust, making the icy moon one of the most promising places in the solar system in the search for conditions that could support life. The mission was only getting started.